For lesson 6, we're going to talk about finding zeros and intercepts. So let's define each of those things first. An intercept is a point, which is an ordered pair on a graph, where a function crosses either the x or y axis. There are x-intercepts and there are y-intercepts. A zero is the location or locations where a function's value is 0. So as you'll see as we look at some examples, the 0 is an x-intercept. So when I say x-intercept, we're talking about finding the 0 of a function. So if we look at this graph, this is the graph of function f, which is negative x plus 2. The y-intercept occurs at 0, 2, as you can see on the graph there, and the x-intercept occurs at 2, 0. Now, I'm going to show you algebraically how we can find that. For the y-intercept, what we know is that a y-intercept always occurs when x equals 0. We learned about that in a previous video. So if I want to know the y-intercept of function f here, then what I want to know is what is the value of function f when the x value is 0. What is the value of the function? So I'm essentially finding f of 0. So f of 0 equals negative times 0 plus 2, and negative 1 times 0 is 0. So f of 0 equals 2, and so I get the y-intercept here is 0, 2. The x-intercept of the function is going to occur at the spot where y is equal to 0. Or, in the case of using function notation, it's the point where the value of the function is 0. So I put a 0 in place of f, and I solve that for x. So 0 equals negative x plus 2. Negative 2 equals negative x if I subtract 2 from both sides. Multiplying or dividing both sides by negative 1 gives me x equals 2, so the x-intercept is at 2, 0. And we saw that on this slide right here. Okay, so this is something very important to remember. The y-intercept occurs at the ordered pair solution with a 0 for the x-coordinate. So if you want the y-intercept, put a 0 in for x. And the x-intercept occurs at the ordered pair solution with a 0 for the y-coordinate. So if you want the x-intercept, make y 0. Now notice that I put in parentheses an s on those words there. A function can have more than one x-intercept, as you'll see when we go throughout the year. Okay, so for example, find the slope and all the intercepts of function g. Okay, so let's find the y-intercept first. Now function g says it's 1/2 x plus 6. So if I want the y-intercept, remember I put a 0 in for x. So that's the same thing as finding g of 0. So g of 0 equals 1/2 x plus 6. I put a 0 in place of x, so I get 1/2. That should still be an x right there. So I get 1/2 times 0 plus 6, which is 6, and so the y-intercept occurs at 0, 6. The x-intercept occurs when the value of the function is 0, so when y equals 0. So I put a 0 in place of g. So 0 equals 1/2 x plus 6. I solve that for x by subtracting 6 from both sides in this step, and then multiplying both sides by 2 here in this step. So 2 times negative 6 is negative 12. 1/2 x times 2 is x, because 1/2 times 2 is 1, and so I get the x-intercept of negative 12, 0. And the slope is easy to find because the equation is in slope-intercept form, so it's the coefficient of x, which is 1/2. All right, now this one's in standard form, so let's talk about the slope and the intercepts again. Let's talk about the y-intercept first. Regardless of the form that the function is written in, this one's in standard form, the fact is still the same, that the y-intercept occurs when x is 0. So in this equation right here, I'm going to put a 0 in for x and solve for y. So 2 times 0 plus 3y equals 12. So that's 0 there, that goes away, and I have 3y equals 12 left. Divide both sides by 3, and I get y equals 4. So the y-intercept is 0, 4. The x-intercept occurs when y is 0. So I put a 0 in for y. So 2x plus 3 times 0 equals 12. 2x equals 12. So divide by 2, I get x equals 6. So the x-intercept occurs at 6, 0. Now the slope in this case is not quite as easy to find because it's not in slope-intercept form. So it's not just the number in front of x. Okay, so here's the equation. What I need to do is put it in slope-intercept form so I can find the slope. Now I do know 2 points on the graph, 0, 4 and 6, 0. So another way to do this would be to use the slope formula, which we learned. This would be x1 and y1, this could be x2 and y2, and you could find the slope that way. This way also works, to solve it for y, to get it in slope-intercept form. So here I subtracted 2x from both sides, right here and right here. So I get 3y equals negative 2x plus 12. Then I divide both sides by 3, and I get y equals negative 2/3 x plus 4. And so you can see now the slope is negative 2/3.